what is meant by pH, and I have told you the difference between the pH is mainly due to H ion concentration, and the water plays the important role there. H2O gives H plus OH. This H ion concentration is measured in terms of negative logarithm, and that is called as pH. pH is negative logarithm of hydrogen ion concentration expressed in moles per liter. This we have seen last time. Now, what is the use of this pH and why we use it to measure acidity, alkalinity, salts, what is buffering, that we are going to study today. As I have already explained to you, the difference between strong acids and weak acids, strong base and weak base. Strong acids and strong bases dissociate 100% in water. Suppose if you take HCl, HCl is strong acid, so it gets completely converted to H plus Cl. 100% conversion. And when it is mixed with the water, this is very low, very less dispersion. So you have got very large quantity of H2O and very small quantity of H. But when this is mixed, H ion concentration 100% is added to it, and suddenly the H ion concentration increases. And this increase in ion concentration will give rise to lower pH below 7. If both are equal at that time, you know that in water, if there is no HCl, this will be having H will be equal to OH. So there will be equality, and as we have seen the reaction rate constant, H into OH, this already we have done, so I am just making it fast review. Upon HOH, that is water, is equal to K, and when it is, this is 1 mole per liter, so if you take it this side, multiply it here, then 10 raised to minus 14. So multiplication of H and OH is 10 raised to minus 14. In water, H and OH are equal. Naturally, H ion concentration is 10 raised to minus 7. So this particular pH becomes 7. Now when HCl is added, H suddenly increases. This increase in H will naturally bring down hydrogen concentration increases. When it increases, it is negative logarithm, means the pH will come down, and pH will be, so when HCl is added, H increases, pH decreases. So as acid added more, automatically pH will go down and down. Generally, any HCl, very small quantity also, I think it is not seen. So we have seen that when HCl is added, even with small quantity of HCl is added, all the H gets joined to the H of H2O, and that increases, that will reduce the pH. So pH will go from 7. If suppose we add NaOH, that is strong alkali. So let us consider strong alkali NaOH. It also gets converted fully to Na and OH. Now this OH, when it is added to HCl, H2O, it consumes all the H and again form H2O. So what happens? That H gets reduced. So H reduces, that gives pH greater. So pH increases. So it will increase 7 to 14. Depending upon the concentration of H or NaOH, this ratio, this 7 will go to 2, 3, 1, etc. This will go to very high level. Generally, when HCl and NaOH are added, HCl will bring down the pH below 4. So pH will be below 4, and here the pH will be above 9. So strong acids and strong bases are not at all supporting life. Living beings or the plant life, animal life cannot sustain at low pH or high pH. And therefore, these reactions, whatever are explained in the chemistry, that is extraction of ore, doing some reactions, etc., heating it, all those things are not at all possible there. So the magic that is done by carbon dioxide to bring the pH in between, the important reason why life originated on the earth. Last time I mentioned that H2O is a polar molecule. And has got exceptional properties. Similarly, CO2 has got exceptional properties because it has got 4 electrons and it is joined with 2 O's in covalent bonds. So it is CO. Fortunately for us, this is in gaseous stage. So it mixes with water. It can dissolve in water. When it dissolves in water, you get H plus HCO3. So here, this CO2, when it is dissolved, it forms acid. Why we call acid? Because H is created. When H is created, you call that substance as forming acid. So this is acting as acid, H2CO3. This is combined H2CO3 is known as carbonic acid. So this carbonic acid, H plus HCO3. This HCO3 is called as now this bicarbonate plays an important role. That suppose there is some H base. So this is called as base. So you have got in an equation both acid and base. So H carbonic acid creates one base as a buffer. So it will have a very good way of pH. Suppose the water has got 7 pH and you have got lot of HCO3, then you need not worry, because suppose what happens that this is carbonic acid, this is this. Suppose we add HCl, then H increases. Suddenly HCO3 will try to bring back H, it will be consumed by HCO3. This HCl increase, H increase is consumed by HCO3. So HCO3 will act as a base and will bring back it to CO2 side. So the base will take up that acid and will again make it neutralize. Suppose we add NaOH. Now if NaOH is added, what happens? Suddenly H2CO3 will become active and it will produce more H. This NaOH gives OH. So this OH will create a lot of problem and pH will increase very high. That will not happen because H2CO3 will provide H and will try to join this. So here in this particular thing, this is acid base pair. Acid base pair is formed. In general, this particular property is observed more in organic acids. The organic acid, I can give you one example, simple. Acetic acid, CH3COOH gives CH3COO plus H. This is called as acetic acid. This is called as acetate. Acetic acid, acetate. Now this also acts exactly acid-base system because this acts like base. This is called as conjugate base. Conjugate means attached with acid. So at the same time there is acid and there is a base. Now when this particular thing is going on, then there is a some, you can say, support for keeping the pH same, because we have got base also. If something happens, base will come around. If suppose alkali comes, acid will go down. So there are two guards for the controlling pH. Now if I consider this acid, so any acid, there can be any acid. Organic acids, you know, there are so many carbonic acids. There is you can say almost hundreds of acids are there. With increasing carbon atoms you can get. So this right as HA, where H represents acid, H ion, and A is the acetate or acid part of that molecule. HA, general formula I have written, so it becomes H plus A. A is the acetate form. This may form the entire remaining part of the organic acid except H. When H is added, it becomes acid. H is removed, it becomes base. So we can write this equation as H into A into acetate concentration upon acetic acid concentration, or I can say here a base, and here I can say acid. That acetate means it is a base, it is acting like base. Acid, this is called as acid. So H ion concentration into base, H into base upon acid gives K. This is the most important equation for buffering action. How the water and CO2 could sustain the life, that mystery is solved by this particular problem. So here I can say that if I take negative logarithm of all this, negative logarithm of all the two sides if I take, what will happen? It will be negative log of H ion concentration plus a negative log of base upon acid is equal to negative log of K of acid. If I have taken just logarithm and when this is multiplication, I have just added. Both are negative, so it is negative log of H, negative base acid and pK. Now if I write, I know the definition of pH. pH is what? Negative logarithm of H ion concentration. So naturally this becomes pH. pH minus this is equal to, I can write pKa. So this is it. So I can write pH is equal to pKa plus log of base upon acid. Now this particular equation is the basis of controlling pH. What is the equation? pH is equal to pKa plus log of base upon acid in molar. In case of bicarbonate, I could write this pK acetic acid plus log of acetate upon acetic acid. In case of bicarbonate, I could write similarly. It will be pK bicarbonate log of bicarbonate divided by carbonic acid. So here it will be HCO3 upon H2CO3. Now you will say, what is there? Anything you have just added and you have just tried. But this gives us a method of manipulating H. Suppose I want to maintain the pH here to a particular level. I know pK value. Then I can just add more acetate or more acid and control the pH. How I can do that? How I can add acetate without disturbing acetic acid? Or how I can add bicarbonate without disturbing the carbonic acid? Now we have seen H2CO3 gives H plus HCO3. Now if I want to have increased HCO3, then I can do that. But increase of HCO3, again H2CO3 will be disturbed. Here we come with salts. There is a sodium bicarbonate, NaHCO. baking soda. That is edible soda. You eat it. So this also dissociates 100%. Na plus HCO3. Now suppose in the water we add this NaHCO3 here by adding baking soda. That means suppose we have an acidity. We take soda, we heat it with water. What happens is bicarbonate increases. If bicarbonate increases, that means base is increased. When base is increased, naturally it will consume H and bring the neutralization. So, increasing bicarbonate alkalinity can stop any acidity. This is a very simple solution. But here there is one another thing. This HCO3 also, HCO3, suppose we are going to add more and more H, then all will get this thing converted. But HCO3 also is there. It also can act acid also. It can act like acid. How it can act like acid? It can give H plus CO3. So at a time, HCO3 has two weapons, either to fight in this direction or to fight in this direction. If it wants to consume H, it can go to H2CO3. If it wants to absorb H or give H, it can go like that. So here this becomes acid. This becomes base. This is called as carbonate.